GIS or Geographic Information System is a framework designed to gather, store, manage and analyze spatial as well as geographical data. Formed out of organized layers of information attached to a corresponding dimensional location, this platform allows users to visualize natural and artificial infrastructures of the world. These computer systems in a way recreate or rather archive the immediate reality through maps and 3D scenes. With this unique capability, Geographic Information System reveals deeper insights into data, such as patterns, relationships and situations, allowing the users to participate in a meticulous and accurate render of the world. ArcMap, QGIS and Esri are only but a few softwares that can be used as a tool in both problem-solving and decision-making processes, as well as for visualization of data in a spatial environment. Immersion of these cartographical systems into games is a relatively innovative concept so far mostly deployed within the military training programs. However, more often video games addressed towards the general public begin to implement such scientific geoplatforms as a modeling base to make the virtual maps as realistic as possible. This opportunity had been opened up by mapping platform called Mapbox, which allows Unity and Mantle users to integrate real-world terrain into the virtual world. Without any prior experience, you can recreate and explore any place in the world in 3D. For example, to have a casual drive around the city of Los Angeles. This technique is often used in military operations, success of which largely depends on the availability of accurate representation of the specified site. The conditions of terrain, airspace for aircrafts, elevations for maneuvering armor carriers, tanks and other various weapons fall under the responsibilities of military field commanders. In order to assess the possible threats of the unknown territories, 3D models are built before any physical applications to minimize the risks for soldiers. In addition, they need vegetation cover, road networks, and communication lines with pinpointing accuracy for optimizing resource utilization. Air operations in a battle environment require similar inputs as land. These include detailed information about the target location, proximity of civilian areas, terrain evaluation and meteorological conditions besides navigational data. Military leaders heavily depend on GIS and global positioning systems to make tactical decisions such as guiding troops, supplies or equipment and ships, informing them of possible threats, problems with the surroundings and also to direct attention to specific areas of interests. The civil application of geographical information can be best seen in the popular video game SimCity or its advanced analog city Skyline. The player, acting as mayor, is given a blank map to begin and must expand the city with the budget provided. The player must supply the citizens services, which include health, education, safety, parks and leisure. These come in the form of different buildings, where each building covers a circular range of service. Memorable since its appearance in the early 1990s, this open-minded simulation allowed users to balance out the political and social pressures of the imaginary worlds. A game without an end target, first perceived as absurd, has proved itself to become a valuable platform to learn, receive constant instantaneous feedback and inform further decisions of the player. Aimed to find its crowd within architects and city planners, it became a hit, allowing regular participants the ability to play God. By playing such virtual games, data could be collected and used to improve the conditions in our cities and more. Using the Glassbox algorithm, City Skyline recreates infrastructures such as water supply, helping the user understand the efficiency of the system's application and driving for the ultimate revolutionary techniques. Combined with real-life representation of the existing environments, these computer simulations become a powerful tool in the smart city era, taking into account not only urbanistic objects in isolation but also the civilian experience. The calculations for a possible flooding of an area can reveal the flaws in the fundamentals of the built city. But the multi-user trial and errors approach can eliminate these bugs at the level of concept design. Another example of infrastructural advancement, operational through the index of happiness within the game, unfolds the central components for transportation systems. Simulation of transportation systems started over 40 years ago, and is an important area of discipline in traffic engineering and transportation planning today. Various national and local agencies, academic institutions and consulting firms use simulation to aid in their management of transportation networks. Independent from its scale, the geographical systems reach out as into the orbits of our planet, tracing the pathways of the satellite and abandoned stations in real time. Scientific discovery games harness the power of crowds and focus on tasks where humans still far exceed the abilities of computers. Exploring the potentials for the role of the architect in the immediate future, it is impossible to imagine the exclusion of collaborative data gathering. Building Information Modeling, or BIM, is a rather recently implemented technology, resembling Google Docs for architects. A simple enough idea, a single digital model of a building that everyone, architect, client, suppliers, builders, environmental managers, can work on. Geo-referenced in its appropriate location, it is a professional version of SimCity. But what if the architectural practice of the present day erases its limitations of infrastructural planning by granting the freedom of self-development to its direct users? Or at least evaluate the decisions of millions of gamers, tested and expressed through the programs sophisticated enough to recognize urbanistic algorithms? Is it possible to imagine competitions entered by the new generation of professionals raised to understand the city as the hyper-objects? Boundless and infinite in their iterations, just as in a game of chess, the players can explore different strategies in world building in the most meticulous and detailed ways. Exactly the same as the military commander prepares for the forthcoming operation using GIS platforms today, archiplayers can prepare for the challenges of tomorrow. Simultaneously, the accumulation of such data can accelerate the machine learning trajectory and provide the artificial intelligence with grounds to operate and learn automatically on how to build for us. Perhaps a distant future to imagine, but a close look on how to turn amusement into serious games.